Hey YouTube, this is my third video in my module on measures of position of data. And in the last video we constructed and defined what we meant by percentile and percentile rank, but also constructed percentile graphs. In this video we're going to say, well, what if I had a set of raw data? Like, I say here a lousy math teacher gives a 20-point exam to 10 students. And the scores are shown here. We want to find the percentile rank, which is what we're doing, of a score of 12. If somebody got a 12 on this, where would they rank compared to the rest of their peers in the data set? So what I'm going to do is I'm going to share with you what I call the percentile formula. But we have a formula here for calculating what percentile you would be in if you had a raw datum, or the set of raw data. So we say the percentile corresponding to a given x value in a data set is given by using the following formula, where we say, well, whatever the percentile that datum is, we're going to find out how many data values were actually below that. And just as a technicality, we usually add a half onto that. And we're going to divide by n, where n is the total number of data. Total number of data. Okay, and so essentially what we need to do here first is actually rank the data in terms of least to greatest. So when I look at this, I say, all right, well, let's put these in order. I notice that 2 is the minimum. We say 2 and then a 3, and we could say, okay, so I have 2 I've done, 3 I've done, looks like 5. Somebody got a 5 on this 20-point exam. And we say 6 and 8, so 6, 8, so 6, 8. And then we get up into the double digits here, so we say somebody got 10, somebody got 12, somebody got a 15, 18, so 15, 18, and then a 20. So just to be sure, I like to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here are 10 students. My question here is this: what percentile would this 12 rank as? So when I look at this data set, I'm going to say 1, 2, 3, 4, 5, 6, 7. It is the 7th datum in the data set. So what I can tell you is automatically, well, they are greater than the 50th percentile, because the 50th percentile would be the datum that is greater than 50% of the rest of its peers. Now, I do want to calculate this, and I want to use this formula up here for calculating a percentile. So I'm actually going to write out things verbatim as I see them. But really, the trick was this. We are going to take however many data are below this datum right here, and then we are going to add a half onto that and divide by how many data there were. So in terms of what I know about this formula already, I know that there's automatically this plus 0.5, and this is something you just need to get used to, but it's there. And we say that there, in this case, there's n data, and 10 is our n in this case. So if I wanted to know the percentile for this, I say, well, how many data were smaller than this? I say 1, 2, 3, 4, 5, 6 things were smaller than it. So we say 6 data smaller than it. We add a half as a technicality. We divide by 10. So we would say that we get 6.5 divided by 10. This is pretty easy to do. We just get a calculator. Not that we need one here, but you would generally take a calculator to do your calculations with. And we say 0.65. So now this 0.65, here's one thing I want to mention. This is our percentile rank. Percentile rank for a score of 12 and is listed as a decimal. So just like any time you deal with a decimal, if we want to turn this into a percentage, we move that decimal twice to the right. So we could basically say that this 12 right here has a percentile rank of 65, or is in the 65th percentile. So in general, it just attaches a number to this to say, look, I know that you had 10 students, but say we're out of 100 students, this person that recorded a 12 would have done better than 65% of the rest of the people in the data set. So more than half by a little bit, okay? So here's what I want to do. I say, using the same data set, let's find the percentile rank of a 6, which 6, by the way, is not, the best score on this. We say, compared to the rest of their peers, where were they? So again, we'll just use this calculation again. We say percentile for a score of 6, we would say it would be this plus a half all over n. So we have 10 students, and we say that 6 is bigger than 1, 2, 3 of the other data. So we get 3 plus a half is 3.5 over 10, which is really 0.35. So we'd say a score of 6, this is in the 35th percentile. And again, all that's saying is, I know that the data set didn't have 100 elements in it, but if it did, we would say that that score of 6 would be relatively about bigger than 35% of the rest of their peers, so not very good. That's how you calculate percentile rank. Cheers.